Hello friends, welcome to my channel. Let's have a look at problem 2187, minimum time to complete trips. In this video, we are going to explain a solution based on binary search. First, I'll read through the problem statement, and then we explain the intuition and the idea, and finally we share the code. So in between, I'm going to emphasize one mistake I made. So with that said, let's start with the main statement. We are given an array called time, where time I denotes the time taken by the ith bus to complete one trip. So the second paragraph basically says that each bus can make multiple trips continuously, and the different buses can operate independently. So we are also given an integer called total trips, which denotes the number of trips all buses should make in total. So we are required to find the minimum time required for all buses to complete at least total trips, number of trips. So this is the main problem statement. So here are two examples. So example 2 is sort of special because there's only one bus. So we want to finish one trip. So it's the time taken here, that is 2. So for the first one, so the time is 1, 2, 3. So notice that by assumption, so this time list is not necessarily in sorted order. But here the first bus is the most fast, and the last one is the most slow. So in order to finish 5 trips, here we need time is 3, right? So here is an explanation. So this is the main problem statement and the examples. So next, let's look at the constraints. First, the list time has a length bounded above by 10 to the power 5. So also notice that this list is not empty. Secondly, time I or total trips is bounded below by 1 and bounded above by 10 to the power 7. So with that said, we are ready to explain the intuition and the idea. So for this problem, actually if you practice quite a lot for Leetcode problems, so this is a very typical binary search problem. Or we can use binary search to do this problem. So for this problem, when I first seen it, so I'm confident that we can make it or solve it easily. However, the main point when I approach the problem is determining the search range. So because in my first 2 or 3 submissions, it was not right. But I know how to fix it. So here our plan is the following. First, I'm going to define a Boolean function to check with a given time duration. So if total trips can be finished. So this is the function signature. So the argument, I'll call it duration. So the function can finish checks if we can finish total trips, number of trips, within the given duration. So this function returns true or false. In other words, it's a Boolean function. So in the paradigm of using binary search, so this step actually is crucial. It produces order or monotonicity. So this can be regarded as step 1. So step 2, with the Boolean function defined above, we would like to transform the problem to the following problem. We would like to find the minimal duration such that can finish duration. This function returns true. So this duration is what we want to return for this problem. So here in the second item above, we need to do 2 things. First, we need to determine the search range. And second, we need to determine the shrinkage and do proper return. So when I first tried this problem, so actually I made some mistakes in start. So this mistakes is sort of silly mistakes. But, even this mistakes because we a priori know that we can solve this problem use this method. So with that said, let me explain the code. So here, because we want to determine the bounds or later, so we are going to first sort this time. So this is not necessary, but after we sort, it's actually save us some time when we do the canFinish function, because we want to check the fast bus and then slow bus. So let's regard this as a preparation step. So next, I'm going to define a Boolean function. Let's call it canFinish. So the argument is duration. So we're going to return a Boolean, right? So here we're going to check if total trips can be finished within duration time. So in other words, the return is Boolean. So with that said, let's write the function. So basically, I'm going to check if we want to, if given this duration, how many trips we can finish. If the trips finished is no less than the total trips, we are going to return true. Otherwise, we return false. So let's see, the trips is going to be initialized as 0. Then we are going to iterate for t in time. Notice that the time now has been sorted. That's why we are going to check within a duration the trips finished, or the fast bus we check, right? So here the trips is going to be incremented by this duration, integer division by t, right? So this is the number of trips this corresponding bus can finish. So here we're going to make a check. If trips is greater than or equal to total trips, so we're going to return true directly, right? So this also serves as an early stopping. Otherwise, so after this for loop, if still the number of trips is not satisfying this condition, we're going to return false. So this is actually and can be regarded as second step, define the Boolean function. Next, I'm going to transform this problem to be find mean duration, such that canFinish the duration is true, right? So for this, actually, originally I was make some careless errors. So here low, because we need at least 1, right, due to this constraint. But the high for the searching range, so actually it should be the largest time used times the total number of trips. For example, you can think if you just have 1, right, so this should be the total trips times the time needed. So that's the correct high, right? So that is times -1. The reason is that we have sorted this list, so the last one will be the largest one, and then times total trips. Or you can add something, right? Add some no less than this number. That will be fine. So this is the high, this low, and in between is a search range. All right. So next will be the standard shrinkage. So if low less than high. So here I'm writing strictly less. Then I'm going to do the shrinkage. So I'm going to do this. So high minus low over 2. Then I'm going to check canFinish. So use this made. So if this is true, then it means that we can find some possible duration which is no larger than mid. So we can set high to be mid. This shrinks half of the range, right? Otherwise, canFinish mid is not right. In other words, we cannot finish that required number of trips. So we are going to increase our time duration. So the low will be at least mid plus 1, because the mid in this else block. So here will be this function will return false in this else block. So with that done, so actually we finished the main binary search step. But the question is what we should return. So because of the way we write the shrinkage, so each time when we use high, so the high always makes the canFinish returns true. So here we need to return high. So this piece of code actually forms a solution format to this problem. So you can try other formats of coding, but this actually just demonstrates one possible way. So before we do any comments, let's first do a check. Yeah, it passes one example. Now let's look at generic case. Yeah, it passes all the cases. So here, let me give a small summary. So first, I did a thought. So if you want to do time complexity analysis, so this thought will be O(n) log n, where n is the length of this time. And then I do this can finish. So here, let me write the time complexity here. Here is O(n) logarithm m, right? So this n is the length of time. So this function can finish. Actually, each time it uses at most linear time. So this function will be O of n. Again, n is the length of this time list. So here, what we are going to do, so we call the canFinish function a number of times. Because we are using binary search, so the number of times we call this one. So here is logarithm with respect to 2, right? With base 2, so you can just write log up to a constant, right? So it's high and minus low, right? So roughly, so we call this number of times of the canFinish function, but the canFinish function is O(n), right? So it's basically logarithm. So here is up to a constant, right? It's logarithm high minus low, because low is 1. We just consider high. So high will be the max of time times the total trips, and then times O of m. Because here I'm writing big O, so I can do not write it here. So or if you like, you can write something like this. Here's yeah. So this similar symbol actually is up to a constant in mathematical expressions, but if you like, you can write it in O of this constant. That would be fun. So this is roughly the time complexity if you want to analyze it. So with that said, basically that's it. I don't know if I finished. I revealed the structure clear. First, I did a thought, and then I wrote a Boolean function to prepare for binary search, and then I determine the search range, and then do the shrinkage and the return. So with that said, I guess that's about it for this specific problem, and also it's the end of this video. So actually, in our channel or in our playlist for binary search, there are quite a number of other problems. You are welcome to check out and practice. So with that said, thank you.